Welcome to the example of linear programming using graphical method. A keyboard manufacturing company manufactures two types of keyboards, P and Q. Both keyboards pass through two machines, M1 and M2. The time required to process each unit of product P and Q on each of the machines and the available capacity of each machine has been given to us. So product P takes 6 hours on machine M1 and 2 hours on machine M2, whereas product Q takes 4 hours on machine M1 and 4 hours on machine M2. We have also been given the available hours per week. So M1 can be operated for 3600 hours per week, while M2 can be operated for 2000 hours per week. Now each unit of product P gives a profit of rupees 25, while each unit of product Q gives a profit of rupees 20. And we are being asked as to how much quantity of each product should be manufactured to maximize the profit. Now let us try to understand this problem in detail. So suppose this is our machine M1 and this is our machine M2, and we have two products. This is P and this is Q. Now we have been given that both these products pass through both the machines M1 and M2. So if we take that first unit of P goes to M1 to be processed, there it spends 6 hours, then it goes to M2, here it spends 2 hours, and then is the final product. Similarly, each unit of Q will go through M1, spend 4 hours, then go to M2, spend another 4 hours, and then come out as the final product. Machine M1 can run for 3600 hours per week, while M2 can run for 2000 hours per week. Now let us consider the product P. Each unit of P has to be processed for 6 hours on the machine M1 and 2 hours on machine M2. Now M1 is available for 3600 hours per week. So if we divide 3600 by 6, we'll know how many units of P can be processed on M1 per week. So P1 M1 is 3600 by 6 is equal to 600 units per week. Similarly, P takes 2 hours to be processed on machine M2, and M2 is available for 2000 hours per week. So P1 M2 is equal to 2000 by 2 is equal to 1000 units per week. So the number of units of P that can be processed on machine M2 per week is 1000 units. Now we have been given that each unit of P has to be processed on both M1 and M2. So even though we can process more units on M2, our constraint or bottleneck becomes the availability of M1. So through M1 only 600 units can pass. So only those 600 will be able to go via M2. So if we consider manufacturing only the product P, we can manufacture 600 units. Similarly for Q, if we take Q and through M1, each unit of Q takes 4 hours on machine M1, and M1 is available for 3600 hours per week. So to find how many units can be produced or can pass through M1, if we divide 3600 by 4, we can get that answer. So 3600 by 4, this is equal to 900 units per week. Similarly for Q on machine M2, each unit takes 4 hours and the machine is available for 2000 hours. So Q1 M2 is 2000 by 4. This is equal to 500 units per week. Now again, each unit of Q has to pass through M1 and then M2. Now M1 900 units can pass and through M2 500 can pass. So M2 is the bottleneck. However, we can pass only 500 units via M1 and M2 because each unit has to be processed on both the machines. So for Q, we can process 500 units. Each unit of product P gives a profit of rupees 25, while each unit of product Q gives a profit of rupees 20. So if I were to go by the profit provided by P and Q, I would definitely go with product P, since the profit is more than Q. And also, just by looking at these two numbers, 600, that is for product P, is greater than that of Q. So I would say, okay, let me manufacture all the quantities that I can for product P because the quantity is higher, and of course we are using the maximum available capacity for M1, and the profit provided by P is also higher than Q. So in that case, my profit becomes 25 multiplied by 600 units, which is equal to 15,000 rupees. Now, this is just by looking at the problem and just looking at the profit and looking at the capacity and not using any methodology like linear programming to solve this problem. Now let's see how linear programming can help us optimize the solution. So keep these numbers in mind, and once we have finished the solution using linear programming method, then we'll come back and compare the solutions. In order to solve this problem, let us first summarize the data that has been provided to us. So we have product and machines M1 and M2. Product is P and Q, and processing time for P on machine M1 is 6 and on M2 is 2. Processing time of Q on M1 is 4 hours and on M2 is 4 hours. This is the processing time in hours. Also, we have been given the available hours per week. For M1 it is 3600 and for M2 it is 2000. And if we note down the profit provided by each unit of P is rupees 25 and each unit of Q is rupees 20. Now let us first note down the decision variables. So first step in order to solve this problem using linear programming method is to formulate the linear programming models. So in order to do that, let us first note down the decision variables. Now in this problem we are being asked to find out how much quantity of each product should be manufactured to maximize the profit. So let us assume X as the units of product P to be manufactured. And let us assume Y is the quantity of product Q to be manufactured. So X and Y are the decision variables. Now the next step is to note down the objective function. Now the objective here is to find out the quantity of each product to be manufactured in order to maximize the profit. So our objective function is to maximize the profit. So let's assume that P is the profit. Now we have been given the profit for each of the products P and Q. So for 1 unit of product P, we can get a profit of rupees 25. Now we are assuming the quantity of product P that we are going to manufacture as X. So for 1 unit of P we get a profit of 25 rupees. For X units we'll get a profit of X multiplied by 25. So let us note that down. Similarly, for product Q, 1 unit gives a profit of rupees 20, and we have assumed a quantity of Y for product Q. So if 1 unit gives a profit of 20, Y units will give a profit of 20 multiplied by Y. So let us note that down. So this is our objective function, and here we have to maximize profit, which is P. The next step is to note down the constraints. So the first constraint that has been given to us is the available hours per week for machine M1, which is 3600 hours. So it has been given to us that machine M1 at the max can be used for 3600 hours. So what that means is that the total number of hours used by product P and by product Q on machine M1 should be less than or equal to 3600 hours. So first we have to find out the number of hours required for P to be processed on machine M1. Now we have assumed X as the quantity that we are going to manufacture for product P, and each unit of product P needs 6 hours of processing on machine M1. So if 1 unit of P needs 6 hours on M1, X units will need 6 multiplied by X hours on machine M1. So this is 6X. Similarly, 1 unit of product Q needs 4 hours of processing on machine M1, and we have assumed a quantity of Y to be manufactured for product Q. So if 1 unit takes 4 hours, Y units will take 4 multiplied by Y hours. So this is our time taken by Y units of Q. So our first constraint becomes 6X plus 4Y is less than or equal to 3600. Now the second constraint that has been given to us is that machine M2 is available for a maximum of 2000 hours in a week. Now this 2000 hours is the maximum that can be utilized by P and by Q. So for P, each unit needs 2 hours of processing on machine M2, and since the quantity of P is X, X units will take 2 times X hours to be processed on machine M2. Similarly, Y units of Q will need 4 multiplied by Y hours to be processed on machine M2. So the time taken by Y units of Q to be processed on M2 is 4 multiplied by Y. So our second constraint becomes 2X plus 4Y is less than or equal to 2000. And of course, our normal constraint for any linear programming formulation is that X and Y should be greater than or equal to 0. So the linear programming model that we obtained earlier is P is equal to 25x plus 20y, and we have to maximize P, and the constraints we have is 6x plus 4y is less than or equal to 3600, and 2x plus 4y is less than or equal to 2000, and x and y is greater than or equal to 0. Now, in order to solve this problem using the graphical method, let us first assume that the horizontal axis, which is the x-axis, represents the quantity of product P, and the y-axis, which is the vertical axis, represents the quantity of Q. Now, since one of the constraints is that x and y should be greater than or equal to 0, the quadrant that we are using to plot these lines is the quadrant where both x and y are positive. So let us first start with plotting the two constraints, that is 6x plus 4y is less than or equal to 3600, and 2x plus 4y is less than or equal to 2000. Now, in order to plot these lines, we will drop the inequalities temporarily. So our equations that we are going to plot is 6x plus 4y is equal to 3600, and 2x plus 4y is equal to 2000. So let us try and plot this first line. Now, since this line represents a linear function, that is, it can be represented in the form y is equal to mx plus c. Hence, this equation will form a straight line on the graph. Now, since x and y are both positive, this line will intersect the y-axis as well as the x-axis. So in order to find the intercepts on x-axis and y-axis, we can put each of these variables, that is x and y, as 0, and we'll find where this line is going to intercept on the other axis. So we have 6x plus 4y is equal to 3600. Let's put x is equal to 0. So we get 4y is equal to 3600, or y is equal to 3600 by 4 is equal to 900. So on the y-axis, this line will intercept at this point 900. Similarly, if we put y as 0, we get 6x is equal to 3600, or x is equal to 600. So on the x-axis, this line will intercept at 600. Now, there is another way to find or to plot this line, that is the method of finding the slope. So we know that 6x plus 4y is equal to 3600. Now let us bring this equation in the form of y is equal to mx plus c. So 4y is equal to 3600 minus 6x, or y is equal to 3600 divided by 4 minus 6x by 4. This is equal to, we'll put x in front, so we'll have minus 3 by 2. If you divide each of these numbers, that is 6 and 4 by 2, you'll get 3 by 2, x plus 900. You divide 3600 by 4, so you get 900. So y is equal to minus 3 by 2x plus 900. So this represents the y-intercept. So we know that this line on the y-axis is going to intersect at 900, and this represents the slope of the line. So since it is negative, it is moving downwards when the line is moved from left to right. So it is coming like this. And for each 2 steps that x takes, y takes 3 steps. So since y is intercepting at 900, the x axis will be intercepted at 600. So x is at 600 and y is at 900. So it's the same result as we got here. So let us draw the line now. So this line represents 6x plus 4y is equal to 3600. Now, since the actual constraint is that 6x plus 4y is less than or equal to 3600, all the points below this line will represent that equation. Now, if you want to verify, you can take any one point. So suppose you take y is equal to 400 and x equal to 0. So if you put in this equation here y equal to 400 and x is equal to 0, so 6 multiplied by 0 plus 4 multiplied by 400, this is equal to 0 plus 1600, and definitely 1600 is less than 3600. So everything which is below this line will represent 6x plus 4y is less than or equal to 3600. So let us shade this area represented by this constraint. In other terms, you can also say that the shaded area represents the feasible region defined by the inequality 6x plus 4y is less than or equal to 3600. Now let's move to the next constraint, which is 2x plus 4y is equal to 2000. So we have 2x plus 4y is equal to 2000. Let's put x equal to 0. So we get 4y is equal to 2000, which means y is equal to 500. Similarly, if we put y equal to 0, we get 2x equal to 2000, or x is equal to 1000. So the second line intercepts the y-axis at 500, which is this, and the x-axis on 1000. So let me extend this line to represent 1000. Okay, so let us now draw this line. So this line represents 2x plus 4y is equal to 2000. So the actual equation was 2x plus 4y is less than or equal to 2000. So in this case, the area below this line will represent the inequality 2x plus 4y is less than or equal to 2000. So let us shade that area. So now the area which is common between the first and the second constraint is known as the feasible solution region. So this area, that is from here to here and the x-axis and the y-axis, this is the feasible solution region. So what that means is that every combination of values of x and y in this region provides a feasible solution. Now here the objective is to find the optimal solution so that the profit can be maximized. So to do that, we'll have to find a point where P can be maximized. So we need to draw the line of the objective function, which is P is equal to 25x plus 20y. So let us do that. So the equation is P is equal to 25x plus 20y. Now in order to plot this line, we have to find out the slope of this line. So let us first express this equation in the form of y is equal to mx plus c. Once we do that, then we'll know the slope of the line and then we can try to plot these lines. So let us bring this x here on this side. So we get 20y is equal to p minus 25x, or y is equal to minus 25x divided by 20 plus p divided by 20. Again, y is equal to, so if you divide both these numbers by 5, you get 5 and 4 minus 5 by 4 plus p by 20. Now here, sorry, this is x here. Now here the slope is minus 5 by 4. So we know the slope. Now if we knew the y-intercept, then we could have drawn this actual line. However, the idea is to find the actual line which can maximize the profit. So we don't know the y-intercept, however we know the slope. So we can draw this line in parallel to each other. On any particular line that we draw for this objective function, the different combination of x and y will yield the same profit, that is p. As p increases, the straight lines will move away from the origin, and the furthest line from the origin will give us the maximum profits. Now what does the slope of minus 5 by 4 mean? So this means that the line is moving from left to right in a downward direction. Also, for every 4 steps of x, the y-axis moves by 5 steps. So let us start drawing these parallel lines in order to find the line which is the furthest away from the origin and which is the optimal solution line. So this is the point, or this is the farthest point in the feasible region from where the objective function line is passing. So let us put some letters in front of the feasible region so that we can easily identify. So let us say this is A, this is B, this is C, and this is D. So B is the point where we are finding the optimal solution. Now generally the optimal solution is found at one of the vertices or one of the edges of the optimal solution. So most likely you will find a feasible solution at either A or B or C, because these are mostly the farthest points in either of the directions. Now there are multiple ways to find the coordinates or the value of x and y at point B. First is by using the graph. If you plot the line, that is, you find the y-axis and you find the x-axis, then you can find the coordinates of point B. Second is that point B is an intersection of the line 6x plus 4y equal to 3600 and 2x plus 4y is equal to 2000. So if you solve these two equations for x and y, the value is the coordinate of the point B. So since drawing on the graph to find the x and y axis may not be as accurate, let us solve the two equations 6x plus 4y equal to 3600 and 2x plus 4y equal to 2000 to find the value of x and y. So the two equations we have is 6x plus 4y is equal to 3600 and 2x plus 4y is equal to 2000. So if we do subtraction, we get 4x is equal to 1600 or x is equal to 400. And if you put x equal to 400 in one of these equations, say the second one, since it seems easier to calculate, 800 plus 4y is equal to 2000, or 4y is equal to 2000 minus 800, which is 1200, or y is equal to 12 divided by 4, which is 300. So we get x is equal to 400 and y is equal to 300. So after solving this problem using linear programming graphical method, we get a solution to manufacture 400 units of P and 300 units of Q. Now if we equate the profit, if we manufacture these quantities, for P we have per unit profit of 25. So 400 multiplied by 25, which is 10,000. And for Q we have a profit of rupees 20 per unit. So 300 multiplied by 20, which is 6,000. So this way we can get a profit of 16,000. Now if you recall, initially when we had done some analysis on the problem and we tried to solve the problem without any models or any methodology, we had gotten a profit of 15,000 rupees. And by using the linear programming method, we have gotten a profit of 16,000 rupees, which is 1,000 rupees more than the other solution. Now, one thing that I can point out is the difference between the two solutions, that is the one that we did without linear programming and the one that we have done with linear programming, is that in the first problem we had considered the constraint of one of the machines. So M1 had a capacity of 3600 hours, M2 had a capacity of 2000 hours. So when we were processing product P, we considered 600 units to be manufactured for M1, and M2, each unit of P took 2 hours. So we could have processed 1000 units. However, because of the bottleneck on machine M1, we decided to process only 600 units through M1 and M2. So what that did is that the utilization of machine M2 was, or in other words, M2 remained underutilized. So 600 units, 2 hours per unit is 1200 hours on M2. So 800 hours on M2 was underutilized or not utilized. So by using a proper combination of P and Q and manufacturing P as 400 units and Q as 300 units, let us see how we get the utilization in terms of time on machine M1 and M2. So the solution is for P to manufacture 400 units and for product type of Q 300 units. Now we have been given that on machine M1 P requires 6 hours per unit and on M2 it requires 2 hours per unit. Q requires 4 hours per unit on M1 and 4 hours per unit on M2. So let us find the number of hours that will be utilized on M1 and M2 for both P and Q. So P is equal to 400 and Q is equal to 300, M1, M2. So 6 multiplied by 4, 24, 100, 2 multiplied by 4, 800, 4 multiplied by 3, 1200, and 4 multiplied by 3, 1200. Now this totals 3600 and this totals 2000. So by manufacturing 400 units of product P and 300 units of product Q, we will be using M1 for 3600 hours and M2 for 2000 hours, and that is the maximum available hours per week for both the machines. So since this combination utilizes M1 and M2 optimally, which is it is using the available time on machine M1 and M2 to its maximum, we get the maximum profit, which is 16,000 rupees.